It is working, yes, Michael. I don't want to finish it. I know, but I have some stuff I want to add. I'm gonna go through like the rules and then some stuff. It's just actually I think it is here. That's a vehicle machine. Is it? I didn't know. Okay, so what did you? Sorry, I really didn't talk like during lunch. I think. No problem.
Okay, folks. So this is chemistry and lab events. I'm Michael. I competed in a number of chemistry events in high school, and this is Rishi.
Yeah, I competed in chemistry lab. I'm the proctor, or I wrote the water flow test last year, and also competed in thermal. So I know somewhat about lab events and chemistry events.
Okay. So this year's chemistry lab topics are acids and bases in aqueous solutions. So acids and bases is a continuation from last year, where it was acids and bases of physical properties. And this year they replaced physical properties with aqueous solutions. So last time this combo came around the chemistry lab, I heard it was a really hard year. So, you know, these kind of go really well together because, of course, like acids and bases are usually aqueous solutions. I guess they're pretty much all the time aqueous solutions, but
Oh, oops. Okay.
yeah.
So yeah, we recommend reading these chapters in a textbook called Zumdahl and Zumdahl. It's the standard AP chemistry textbook for the entire nation, basically. It's a really good way to digest the information in like a. It's pretty accessible.
Yes.
It's very like it's beginner and intermediate level. So we recommend these 4 chapters. Typically, Zumdahl and Zumdahl will group these chapters in like topic sections or topic areas. So these are the solutions chapters. So yeah, solutions properties, equilibrium, which is like not covered in this event, but it's a good way to get the fundamentals to what solutions and acids and bases are, because they're fundamentally like equilibria related. Acids and bases, of course, that entire chapter is like amazing to like just like understand acids and bases as a fundamental like concept. And then chapter 15 is applications. So solutions, actually, if I wanna, I'll bring up solutions, the rules, really quickly because it's really funny.
And one
How-
more thing, like if you look at the QR code, that's like we're not affiliated with Amazon at all, but that's like the Amazon like webpage for like Zumdahl and Zumdahl. So if you don't already have it and you want to buy a copy, it's really inexpensive. It's like less than $10. Like I went ahead and bought a copy when I was studying for chemistry lab because it was just so cheap.
And you don't have to buy a copy. You can find a copy online at libgen.is. That's libgen.is. If you just look up Zumdahl, you can find the latest edition for free, pirated. libgen.is, if I'm getting that right. Okay, so the reason I think solutions will be hard and pretty broad this year is because of this first line in the solutions rules. If you can see here, it's part EI. This really gives the writer of a test leeway in how they want to write the test. So when I look at this, I see like barbecue chicken. Like I can put anything on here that I want to. I can put how to separate BaOH2 and NH3 in solutions by various processes. I'm thinking I can put like what KSP is and describe like how KSP is related to like like properties of like the molecules, and so on. So that's why this gonna be pretty broad. They're gonna have to like study like a large range of chapters in Zumdal. I think like and then there might be a fifth chapter they can cover as well, covering like anything extra about solutions. Um, they're also gonna cover like properties of solutions. So that's osmotic pressure, uh, boiling point elevation, freezing point depression, and other such things. And so yeah, so what can happen when rules are vague as well is you get questions like this, which was on last year's ChemLab test for regionals. So the physical properties is also pretty vague. They say to cover boiling point, melting point, etc. This is boiling point. It's a boiling point question, but it's not really within the scope of I guess the what the event is looking for. But they can ask this question, and they can justify it by looking at the rules. So that's why your kids have to like look at a broad range of um, like resources and like chapters to study for. Okay.
Okay, so for like all these lab events, what I'd highly recommend is some sort of practice schedule because in the end, even if you like theoretically know what to do in a lab situation, when you actually get to the tournament under some sort of time pressure, like you can just freeze and forget everything about how to run a lab. So I'd recommend actually like practicing labs regularly. So what I did was I had a really close relationship with my chemistry teacher in high school. He was a super cool guy. So like I was able to go to his like room after school and sort of practice for Science Olympiad there. So I think those like relationships with staff are very important. People who will just let you hang out in their room and practice Science Olympiad. So what I'd recommend is like after school, maybe like once a week or once every 2 weeks, is actually doing some sort of lab under a time pressure with your partner, so you guys can get like familiar with what each of you are going to do in a lab situation, like what are your strengths and weaknesses. So one person is really good at taking the lab data and analyzing it to actually write the solutions in the test. Then understand you can understand that. And this like practice is always just good to get more efficient during the exam because of course it's a timed exam. So um, as well as the actual lab portion, you want to be doing practice tests. So last one of the seminars talked about resource procurement. So having practice tests is pretty important to make sure you understand after you learn the content to actually check that you understand the content. One of the things I caution against is it's really tempting to just look through an exam and look at the answer and say, oh, I knew the answer to this question. But in reality, it's just you're justifying that you knew the answer after the fact. So
Also, I'm just gonna say this, guys. One more thing. Zumdal is pretty great with like putting sample questions in their text, and I'm gonna pitch Zumdal as like often as I can because I love the book. I have a copy of it myself. It's really great. Like they have sample questions that they can work through and like so they can look at numerical answers and figure out like how they got there conceptually. So that's also good to work through.
okay, so this is like some sort of like kind of practice schedule that I would have had in high school. Don't be intimidated by the time blocks. The times only go from 11 a.m. to 5 p.m. So what I would do is I'd maybe spend like on 2 days of the week, I'd spend like an hour like reading through a textbook and taking notes or watching like Khan Academy videos or something like that to like understand the base concepts and the rules. So maybe work through a couple pages of Zumdal every day and do like the sample problems that they have throughout the text. And then I'd meet with my partner maybe once a week to like actually do like either discuss like what I learned that week or take a practice test or do a sample lab. Um, I know for this, I know some people go a lot more aggressive. Like Rishi studied a lot last year for chemistry lab, which is probably why he was so good at it. Why he's so good at it, but really I think it's up to your students. Just have like some sort of baseline expectation for practicing and make it consistent. Because a big part of practice is after you do something consistently for about a month, it is a lot easier to do afterwards because it becomes a habit. So you want to make sure that like you want to do consistent practice basically. And one other thing, have you guys heard the Pomodoro technique? So it's like a super useful technique for studying like content. The idea is it's named after like Pomodoro means tomato in Italian apparently. But the idea is you set a timer for 25 minutes or a similar interval of time, and you promise to yourself that for those 25 minutes, you're just going to focus on the activity at hand. So like put away all distractions. Make sure your phone is like not anywhere near you, like the TV's off, like any distractions are away. And you just do that activity for 25 minutes. And after the 25 minutes, you can reward yourself with some sort of break, do something you enjoy, and then go for another 25-minute session.
Oh, my bad.
Okay, so this is like a sample lab that like a student might see this year for aqueous solution. So like you might be given like a beaker of water with an unknown amount of table salt dissolved in it, and you're given a small amount of sodium chloride. So what kind of ideas do you have for how a student might be able to determine whether the solution is undersaturated, saturated, or supersaturated?
Constant at the bottom. So there's anything at the bottom that is still
Mhm.
in its solid form.
Yeah, for sure. Like the way you test it is you just put a little bit of just like table salt in it, and if it just dissolves, it's undersaturated. If it just falls to the bottom, it's super saturated. And if like stuff actually precipitates out, then it's supersaturated. So for these kinds of labs, you can also like use context clues to kind of maybe give you a couple hints into what the solution is. So if you see like a pristine beaker, then you can probably determine that it's either saturated or undersaturated. Because generally it's really hard to make a supersaturated solution. So like you'll see like if any like droplets of the solution got onto the side of the beaker and dried up, you'll see like crust, crystallization from all the salt that comes out. So it's in these sorts of labs, it's very helpful to like use context clues to help you solve the problem as well. Okay, food science. So I'm not super familiar with food science since I actually never did the event in middle school, but for some of the biology topics, I definitely recommend Khan Academy, like because it's a middle school event. Like I love Khan Academy; it walks you through the topics really well. And the other big topic is fermentation. So it's hard to find like some sort of textbook on fermentation. So I'd definitely look at online resources. I know this one website that I found had a nice overview of fermentation. So honestly, just encourage your students to go out and like go through the rules and study all the fermentation topics because I don't think there's like a single like great resource for like studying all those like a textbook or something. Yeah, another big part of the food science event is they have a couple of hands-on activities. Again, I'd recommend practicing these activities. One of which is you need to find the salinity of solutions. So this is an example of like a super simple salinometer you can make. The idea is, so if you put more salt in a solution, it becomes more dense, which means it's easier for things to float. So this is a really simple way to make a salinometer. All you take is like some sort of sturdy plastic tube, like a straw. You put a little bit of modeling clay at the bottom, and you just put it in solution and see like where it floats or not. And then you can mark that. And you can change the concentration of salt in the solution, and you can see how high the straw rises, and you can mark for each of those concentrations. So this is like a super simple salinometer you can make. The QR code just leads them instructions that Science Olympiad actually publishes on how to build one of these things. Of course, you can go a lot fancier with this if you want to. You can also build like an electronic solution. So the conductivity of solution will change depending on how saline it is. So you can put together an Arduino that actually measures the conductivity of solution, and you can test that against reference samples to kind of construct a curve for conductivity. So that's another way you can build a salinometer, but this is like a super simple way you can do it during it, like before a competition.
Okay, so some general lab practice tips. I'm going to be using anecdotes from my experiences for this slide just because I've seen it all in 2 years of competing. From what I understand, like lab events are like governed by Murphy's law. What can go wrong will go wrong. So this is like so we were competing at MITA 1 year, and we got in the room and we are like sort of like looking forward to it. It was a good test. We were gonna expect a good test, but it was 60 pages long with a 10-page lab, and we had like an hour to do it, and it wasn't very easy either. So I was there sweating bullets for like an hour, and then an hour afterwards as well. My lab mate was also sweating bullets. He was just, like running around the lab trying to figure out like what to do for the lab, and so it was just like not a very good time. And that's an extreme case, but that showcases like these events are pretty they're time sensitive. They have a lot of time pressure like as a component to them. So Because for study events you have like one test for two people. It's like you have like you can do like half tests in like over like 50 minutes versus like lab events is like a pretty long lab, a long test, one person for each thing, and it has to be done in like 50 minutes as well. So like labs and tests are designed for like one whole time block typically. Um, and then so another time at state, I think, and this sort of like encapsulates like troubleshooting on the fly. My partner and I were supposed to do a titration, and it's a pretty straightforward titration. They gave us the instructions to do it, but the clamp, we couldn't figure out the clamp, which was very perplexing to me because everything else went fine, but the clamp was the sticking point. My I was doing the test, and my lab partner nudges me and says, "Okay, how do I do this? How do I work this clamp?" And I look at him, I'm like, "What?" And then I sort of look at the clamp, try and figure it out. I can't figure it out. It was at A&M, so they have some weird gigam stuff over there. I guess. And so we couldn't figure that out. And then it took like 20 minutes to figure out how to use a clamp. And then by the time it was getting, the time pressure was on us, so we had to do everything pretty quickly. And that sort of like encapsulates like two of the things here is time pressure again, and like just working out how to use equipment. It's not gonna always labs aren't gonna always work. You'll never know like what they're gonna look for in a lab. There was one lab um, I did in Rice where we had to separate salt, sand, iron filings, and poppy seeds. And so the first four are pretty straightforward. The issue is that we didn't know how to separate poppy seeds because they would also sink like the sand. Um, and so we spent a long time trying to figure that out. We didn't figure it out actually, and it turns out like in the answer key when it came out, in this windowless room, we had to find a place to like shine light on it so like the poppy seeds would like rise and photosynthesize, I guess, to like so they'll like float, which like I would never know how to do that. I don't think I still understand like what happens for that to happen, but like labs aren't always gonna work. You're not gonna always get the lab correct. So the important thing at the bottom of it all is not to panic, because panicking is gonna waste time on your part. It's gonna make your like partner nervous. You're gonna be more prone to make mistakes, like breaking a test tube, getting iron filings inside or like magnesium filings inside a burette that you can't get out. Which yeah, I know it was pretty bad. That's pretty bad.
Also, don't be afraid to use context clues. Don't feel like you're limited to what you think the proctor wants you to do for the lab. So, for example, at the state tournament, we had to determine a mystery metal by finding its density. So you just put it in a bunch of water and see how the volume of the water changed when you put the mystery metal in it. So that year it was magnesium, but it wasn't magnesium pellets. It was like a weird. It looked like they melted the magnesium and like dropped it.
It was shavings, right?
It wasn't shaved. It was like
fake?
basically there's a lot of room for air bubbles for the magnesium, so it's very hard to get the lab to work. But my partner and I, like having done like enough chem lab, we knew by looking at it that it was magnesium. So we would just flick the side of the test tube that we put the magnesium in until the volume reached what we expected it to reach. Because then we knew that the air bubbles were gone. So if you can figure out those context clues, like using all like your other knowledge to figure out like whatever you need to figure out, to help you actually complete the lab, like definitely do that.
Yeah. So yeah, those are some of my funny stories.
Okay, so density lab. Again, we would recommend like the chapter on Zoom doll that covers gas laws. So only the first part of the chapter from 15.1 to 15.3, because this year's density lab rules only covers like the basic gas laws, which are like Boyle's law, like Guy-Lussac's law, stuff like the any ideal gas law. A big component of density lab is also the like the physics of like buoyancy and stuff. So I recommend like there's a Khan Academy like series of videos on fluids in their physics like class. So those give like a great overview of all the topics you need in density lab. So again, practice the practical activities because the practical activities and scenarios are supposed to be 50% or more of the final score according to the rules. So you want to make sure you regularly practice these kind of things with your partner. especially these are taken straight from the rules. Especially make sure you know these because I'm sure a lot of proctors are not gonna like sit down and try to come up with like a completely unique scenario. They're either gonna use these or use some variation on the theme, like maybe slightly change up like these specific practical activities. So again, like you can sit down with your team and maybe like team members can come up with different activities for like the people competing in the event to do. And every week you try to do these events under some sort of time pressure. So time yourself for maybe like 10 minutes to figure out like each of these practical activities every week so that you're like, so that you guys are super familiar with what to do in sort of test
So I
situations.
have a question.
Yes.
About, because this is my first year doing this with someone else who's been doing it for a while. We have like 60 kids in my classroom,
Yes.
middle school kids. And so I guess I'm trying to like, and maybe anyone has tips like on logistics of how to get the kids to be able to like have the time and materials to practice this stuff. There's so many of them.
I don't know if this is super applicable for your situation, but a lot of the time what I would do is I would actually go to my partner's house like over the weekend or something and just like practice like one-on-one with them. So I would definitely recommend if you have like the resources, like do some maybe like breakout sessions for like different groups of events.
Mm-hmm.
So like people who are doing like this that are practicing with other events.
Come in on a certain day and that.
Yeah.
Um,
Yeah. So like yeah.
Also, you don't really need to have materials per se. Like, if we go back to Chem Lab,
Yeah. All of the
I can
time,
do this. This is a conceptual like lab. Like, they can like ask you this, and you can like show them like what you did. I guess if they want to verify, but you can do this conceptually. Also, I think the lab I put up as part of like last year's lab, we could have done as well, like conceptually, like numerically, not without you doing the actual like lab itself. So it was like a titration. So you had to like find the molar mass of the base, I think, that I used to make the solution. That if you just make up some values, like make like a step-by-step algorithm on like how to like solve the lab, like what I'll need to measure, how I'll measure it, etc. And then you can go from there. So it doesn't have to be like always with materials. You can always like dry lab it. Dry lab it. Yeah.
Yeah.
Okay.
Okay, protein modeling. So if any of you are doing protein modeling, I'd say like pretty much one of the #1 resources is the Milwaukee Center for Biomolecular Modeling website. They pretty much have like almost everything you need for the event on that website. So I can pull it up really quick. So the idea is this is the website, and you can just say I'm a participant, and they have tabs on like if you click this year's theme, they have tabs on like literally almost like a ton of like the event. So part of this year's event is the CRISPR-Cas9 system. So they have videos walking you through like how the system actually works. So make sure you watch all of this. Make sure you also understand what the protein that this year is covering actually does, because the written portion of the test is split into like general protein modeling concepts, but it'll also ask questions specific to the protein this year. So make sure like you have a basic overview and understanding of what the protein does. This year it's cytidine deaminase. It performs some important biological function. One thing you might want to also check, a lot of the times tournaments will use the test from EMSO, the Milwaukee School of Engineering. So this is their resource. If you're taking their test, they're pulling most of the information from here. So there's also, let me see where it is. They also want you to understand DNA structure. So at the very bottom of this, of the second tab, there's this DNA article, which I'd highly recommend everyone who's doing the event reads, because EMSO is probably going to take a lot of questions from this. And it's also good to have a general understanding for other test writers who aren't using EMSO's exams. And if you have like trouble building the pre-build, they also have instructions on how to build the pre-build and the on-site build as well. Another big part of protein modeling is JMOL. So it's the program that you actually use to visualize the protein, and you need to use the that visualization program to build the protein. So this is what this year's pre-build looks like. So this is honestly like a complete mess. Like you can't build anything from this. So you need to understand like the basic JMOL commands to get this into a form that you can actually use to build. So I've outlined them here. You guys can like take a picture of this, but this is from this year's rules. So you type in these commands into the JMOL editor, and it'll give you like the exact model you want. So what restricts does is it restricts the protein from residue just means amino acid, from amino acid number 214 to amino acid number 310. So the pre-build always like only does a subset of the protein. So if we do this here, as you can see, like a lot of the protein just disappeared because now we're just focusing on this year's event. The next thing you want to do is do backbone only. So this current model shows every single atom inside the protein, but the pre-build and the on-site build for protein modeling only want you to do the structure of the backbone. So in order to restrict that, you say backbone only, and then now you just get like the actual like backbone, which is just the carbon atoms that make up like the backbone of the amino acid. Next, this is also very hard to look at because the lines are so thin. Next, you want to increase the size of the backbone, so you type in backbone 1.5, and that just makes it bigger to see. And then finally, the most important part of the protein modeling pre-build is that you get the secondary structure right. So that's the alpha helices and the beta pleated sheets. You want to make sure that you build those because a lot of the time the rubrics for protein modeling want to make sure that all your alpha helices are the right length and in the right position, and that all of the secondary structures are like in the correct relationships to each other. So to make that easier to see, you just type in color structure, and then it will color the secondary structure for you. So the yellow is the beta sheets, and these this pink is the alpha helices, and then this purple is like a special type of alpha helix that has like a slightly different structure to the normal one. So yeah, now that you have this, it's much easier to actually build your protein than what we had before. Yeah, and one important note about building your protein, one thing that students mess up pretty often is making sure your alpha helices are always right-handed. So super easy rule of thumb is if you imagine that this alpha helix is a staircase, you can imagine walking up the staircase, and if you're putting your right hand on the handrail of the alpha helix, that means that your alpha helix is right-handed. So if I'm like walking up this alpha helix, I would be putting my right hand on like the outer edge of the alpha helix, if that makes sense. Yeah, that's a great way like to make sure that your alpha helices are right-handed, which is pretty important. Yeah, that's JMOL. Okay, yeah, some like general pre-build tips. So you want to, part of the event is building functional additions to the pre-build. So these are some of the ones I used when I was competing in the event. So important side chains. So the idea with cytidine deaminase is it binds to substrate and catalyzes a reaction. So any side chains that are important for actually binding to that substrate, definitely include those. Don't include every single side chain because they specifically usually say in the rubric if they use every single side chain, don't give them points. So only model the important ones. So like the things that actually like directly interact with the substrate. So the EMSO event, they only want you to model a specific part of the protein. But if another part of the protein is also important to its function, you can model that as well, and that's considered an additional addition. You can also like directly make the substrate. So you can like maybe like model what like the thing that goes into the protein looks like. And then finally, if your high school students have any sort of like organic chemistry background, if you can draw a mechanism for the actual chemical process that goes inside the protein, so like which atoms like bond, like which bonds are broken and which bonds are formed, that gives you a lot of brownie points. I know a couple of years ago when LASA had a really good protein modeling team, the proctors absolutely loved that. So if you can do it, definitely include it. If any rubrics are released from competitions, make sure your proteins follow those. So all the competitions will use the EMSO rubric. So if you get your hands on that, like just follow that to the T, and you'll have like a really good pre-build on your hands. Yeah, and make sure to view the model from different perspectives as you build it, because if you build it just from one perspective, then usually you don't get the structure right. Yes.
So you include in the actual, once you've done with the model, you can include the mechanism there as a, like a.
As a piece of paper or something. Yeah.
Okay, and so when you impound, you take that with you, right?
Yes.
So you bring this, okay.
Mhm. Yeah. Like whatever like you're displaying your protein on. Like I've seen many different methods for actually displaying the protein. Some people like use strings to hang it up. I use like a piece of plywood and I put dowels straight up and down into it, and then I like slid that through the alpha helix. That's another way you can do it. Yeah.
Because they have to be able to remove it, right?
Yeah, I believe so. To look at it, or it should be like unobstructed, so the proctor can actually like examine it to make sure it's correct. Yeah. Okay, forensics. A lot of this also applies to crime busters. I never did crime busters, but I did a lot of forensics in high school. So I'd say probably one of the most important parts of the competition is identifying the powders. That's usually like gives you a lot of points, and that almost like always like helps definitively solve the crime that you're trying to solve. So definitely practice identifying powders. Like when you're crunched for time, it's a lot harder than like you think to actually identify the powders. And maybe if some of like the telltale signs of the differences between powders can be pretty subtle. So you want to make sure that like you have good practice, like understanding like what to look for when you test the powders. So what I would recommend when testing the powders is already like instead of just randomly mixing reagents together, come into the tournament with a game plan for how you want to test the powders. So what my team did is we had a flow chart of like we would first do this to all the powders, and then we do this to all the powders, and then we do this to all the powders. So usually the very first thing we did is test the solubility of the powders. So we like took a test tube, put water in it, and then put a little bit of the powder in it. You don't want to do too much because if you put too much powder in, it could be soluble, but like reach its max, like become a saturated solution. No more will dissolve, and you'll think it's insoluble when it really isn't. So definitely don't overdo the solubility test. But this usually divides like the powders into two very clear groups: the soluble ones and the non-soluble ones. Then after that, I usually tested them with like the acids and bases and see if there are any reactions. Usually those are pretty definitive as well. One tip on the bases, at least for forensics, is one of the powders is ammonium chloride, and if you mix that with a strong base, it'll form ammonia. So if you like have a test tube of it and you like waft it, then usually you can smell like a little bit of the ammonia, which is a great way to tell if you have ammonium chloride. Also, one thing that is a super useful indicator is the like whether the reaction is exothermic or not. So some powders, when dissolved, will release heat or take in heat. So for example, if you're trying to tell the difference between lithium chloride, potassium chloride, and sodium chloride, lithium chloride is a pretty exothermic when it dissolves, but potassium chloride is pretty endothermic when it dissolves. So that's another like good way to tell the difference between those. After you do all of that, then I'd say do some of the more time-consuming ones, which are the flame tests, which are always kind of tricky. Which you just like take a little loop, like get a little bit of your dissolved solution and hold it over the flame, and then the iodine/Benedict's tests. So cornstarch is probably the easiest powder to identify. Just put iodine on everything that doesn't dissolve, and if it turns black, like that's cornstarch. And probably, in my opinion, the hardest powders to identify are glucose and sucrose, because sucrose pretty much does nothing with any of the reagents. So you don't really have like a positive identifier. You have to rule everything else out. So if it doesn't like do anything in the flame test, if it doesn't react with acid, if it doesn't react with base, and if it's soluble, the last thing you need to do is test it with Benedict's, and if it turns like a dark red color after you do Benedict's test, then it's glucose, but if it doesn't, then it's sucrose. So those are usually the last powders that get identified. And unfortunately, I'd say those powders show up really commonly because like it's really easy to just buy sugar from a store. Yeah. The next part that's important for crime busters/forensics is all the polymers. So you need to identify hair, fibers, and plastics. Hair, I'd recommend just going on Google Images and finding like as many pictures of the different hairs as possible. Like, I mean, the proctors for these events, they usually just go to Google Images and find the pictures of the hairs because generally, like, tournaments will not have the resources to like set up microscopes with that specific hair sample that you can identify. So usually they'll have pictures, and sometimes you can literally find the picture that they used for Google Images. So definitely have a lot of pictures for each hair. A lot of examples for each hair in your cheat sheet, and you get like a ton of pages, so just go crazy. The fibers, I would say, have a ton of pictures as well. Also, like actually have practice like doing the flame test with the fibers, because sometimes it's hard to tell the difference between them just by like looking at an image. So if you have a physical sample at the tournament, make sure you know like what the signs of the polymers are when you put in the flame test. And finally, plastics. So usually what they'll have are like little plastic pellets, and you want to determine the density of them. So what my partner and I did, we made like a matrix. This one says powder table, but you can also do this for polymers. So we'd have like polymers on this axis, and then a bunch of common solvents they had at the tournament. So for example, they super often, a lot of the time, they had like water, of course. They had like a saturated salt solution of water. They had like isopropyl alcohol, and they had like some sort of oil or something like that. But the idea is you want to know beforehand if the polymer will sink or float in each of those solvents, and you can put like a green for float and a red for sink. So then once you test the polymer in every single one of the solutions, you know exactly, you can just follow like the boxes and tell which polymer it is based on like whether it sinks or floats really quickly. Okay, and then chromatography, again, this is just something that you should practice a lot. One thing I'd say I definitely recommend is like a binder clip and a skewer to make sure you're like you clip the top of the chromatography paper with the binder clip and put a skewer through like the ends of the binder clip, if you can imagine that. And then you can hook that on top of your beaker so it doesn't stick to the side of the beaker and ruin your chromatography. That one, chromatography is really straightforward. It's pretty much the same at every single event, so just make sure you have good practice, like setting up a chromatography and running it. Okay, these are some of the remaining event items, and these I'd say like show up super often. Fingerprints, DNA, glass, blood, and spatters. For spatters, go to the Styley.org wiki and look up their spatters section, and that contains like 90% of the information needed for spatters. Like usually all they ask are like if you have a blood pattern that looks like this, what was the angle of the blood when it hit the ground? Like they don't really ask anything beyond that usually, unless it's like a really high quality exam. For blood, you just want to make sure you know all the blood types out there, and if you mix O type with like the antigen, what happens. So you want to be able to know how to identify blood that way. For glass, you should understand like index of refraction, and like Snell's law kind of stuff. A question that events like to ask super often is if you put plastic or glass in like some sort of solvent or some sort of fluid and it disappears, what happened? And that just means that the index of refractions of the fluid, yeah, they're the same. So, yeah, they ask that for some reason. Proctors love asking that question. But yeah, DNA. Pretty much all the time, the DNA I think will be like a gel electrophoresis of the DNA, and you just need to match up like the different bands with like the different like samples. So just get practice doing that for practice tests. And then finally, fingerprints. They almost always have a fingerprint section, and you need to identify the different like types of fingerprints. But you also need to match the fingerprints to the suspect fingerprints, and that's actually not super easy because sometimes the tests aren't printed like on super high quality printers, so it's hard to read. So I'd say this one you just need practice for. The rest of the items in the forensics exam, honestly, I have almost never seen these show up. There's like they can ask about like the bugs and like dead things to see how long they've been dead. I mean, you can study that under like a brief overview, but I definitely say everything above that is much more important to get nailed down because I very rarely see these. Like, I don't think I've ever seen a seed/pollen question. I think I've seen a couple like tracks question, but nobody's ever asked about soil. I think I've seen like one bullet striation question, but that question wasn't that hard. You just need to match the bullets. Honestly, at the end of the day, forensics is mostly like a time crunch to make sure you get every single evidence identified. So again, I would just say after you get like the initial understanding of how each of these tests work, just practice, practice, practice. Like have someone like pick out a bunch of powders and randomly mix them. One of your friends to do that, and then like identify all of them and see how many you got right, and just keep practicing because that's how you do well at this event. And in the end, always make sure, even if you haven't covered all the evidence, always make sure you write like the solution to the crime because that's usually worth like 60 points out of like a 150-point test. It's worth so much. So make sure you always do that at the end, even if you haven't gotten all the evidence down.
Okay, so water quality. I've not competed in the event, but I definitely have written the past two tests at UT here, and from what I've seen, it's very conceptually broad. This year the topics are coral reefs, water management, and there's also like a build portion to it, the salinometer, which is like not too complicated. We already went over it before, so I'll skip that. So it's conceptually broad. It covers ecology. It covers I think like taxonomy of like different corals. Even though you only have 2 pages for notes, which can be like very difficult to fit them all in. From what I've seen, competitors usually use like font 4 and like many pictures on their notes because like the way the tests are written, like they're not going to pull anything from like not Google Images. So I'll always use Google Images to like find your organisms to use. In terms of like other things, it also covers wastewater treatment, which like there's no real like textbook to like learn about that stuff. It's like a very niche topic. So I recommend just Googling wastewater treatment. There's really no courses for that. Khan Academy is a good source for like ecology, basic chemical principles for like acids and bases. Some like coral biology, I guess, or marine biology. So yeah, I would pretty much use Khan Academy mostly. Campbell's biology and Zumdahl go a little too in depth into the some concepts for me to like recommend using them like to search for this event, but they can be a good like I guess skimming them can be a good launching point into like Khan Academy. Googling other stuff and Googling the like concepts that are in the rules. Yeah, this is a very conceptually broad event. Like I've written questions on anything from like how pH is affected by like rocks near the water to like why is this bug confused with this bug, which is yeah. So it covers it all. It's pretty difficult to fit it all in like 2 pages of notes, I think. Sorry, question? Okay, cool. So yeah, it's really about using small font, as many pictures as you can, on those 2 pages to like cover all your bases in terms of like what like different pictures I could have for like different corals. Yeah, and I think that's it.
Okay.
So,
Yeah. Any questions over any of the lab events so far?
I have one. Someone brought this, South Falls, brought this to my attention. Evidently, the chemistry lab has a list, like a huge list of supplies.
Yes.
So is everybody supposed to get those supplies and bring them with them?
Yes.
Or are we gonna provide them at each invitation?
So you're required to bring those supplies with you to the invitational. So I think what we did, like what I know from Zemlix last year, is they use like science department supplies as well as buying their own. You can easily find beakers and pipettes and pH paper like on Amazon. They also sell a kit, I think, on sewing. If that's we're pulling up,
I think so.
But then the more like they have they have a list. So here's the list. The more like I guess niche instruments like burettes you won't need to bring. That's all. That should be provided by the tournament itself.
Also, all the forensics like reagents, they'll also provide.
Yeah.
But there's if you look up just like chemistry lab on the Swank website, this is for Division C. They will literally tell you this is exactly what you need to bring. This is what they recommend you bring to the events.
So we're all supposed to bring it rather than the invitation providing it?
All of these listed here,
That's
yeah, you
how it
have to
works.
bring. It used to be like the invitational would provide them, but they changed that up, so now the teams have to bring their own.
And just like to like save money, I guess you don't really. So I've never ever used petri dishes, spot plates, really like at all when I'm in like tournaments. I also
That's for chemistry lab.
Yeah,
I
for
use
chem lab.
like spot plates all the time in forensics because
So-
it's really easy to just put water, put acid in each of the little wells, and then wait, is that? Yeah, I know them as well plates, but you put acid in each of the little wells, and then you put powder in each of them, and you can run all these reactions at the same time. But for chemistry lab, it's more macro scale stuff. So
You wouldn't really need to use that.
Yeah.
Okay. Any more questions?
yeah, I guess any other questions before we break for lunch?
You got a slide with
Yes.
protein modeling resources?
Yes.
Yes.
Put that back up?
Yeah.
Is it here?
Up.
This one?
No.
No. JMOL? This
That
one? Up more?
One
Okay,
more.
cool.
Yeah, that one.
Yes. Yeah. You can also just look up Milwaukee School of Engineering Science and Olympiad and it'll bring it up. But yeah, I definitely recommend that one up there. If you need more general biology, Campbell's is a great textbook, but that's a great place to start.
Also, you said that the tester on YouTube is
Yes, and usually tournaments will use the test from ESO, which covers the same content every time. Yes.